We have two decisions because they have to hire, oh, this is bad that they both start with C. I guess I actually have to spell them out. One decision is cashiers, the other decision is clerks. So it's like a spaces question because we have two decisions to make, but within each decision, does the order matter? No. So if I'm choosing my cashiers, there were 7 applicants, I need to choose 3 of them. And for clerks, there were 8 applicants, I need to choose 4 of them. And we could type this into our calculator. If I change this, because sometimes on multiple choice on non-calculator, they actually have the answers written out like that, where you just plug things into the formulas, and it has a whole bunch of factorials, and you just choose the right answer from those factorials.
Yes. On the test, is there both non-calculator and calculator?
Yes. So there's, and this unit I think I have more mental math for you to do than normal. Could you do these mental math? Right? Can you see this is 35? How do we expand? We go 7, 6, 5, until you get to 1 on the bottom, you stop at 4 factorial, because those would cancel out nicely, and then you'd still have 3 factorial on the bottom. Anybody know what 3 factorial is?
6.
That's 6. So that would cancel out with that, and you're just left with 7 times 5, that's 35. Mental math isn't crazy. It's doable. Some of them are a little bit harder. But combinations tend to be ones we can maybe do with factorial simplification a little bit easier. All right, questions on this one? 12, 13, 14, 15, and 16. And I have a note that we should do 15 together. So let's do that right now. I'll pull it up. Oh, they're probably algebraic ones, if I remember correctly. Yes, some of them are algebraic and some of them are not. So sometimes you'll get these questions, and we'll do A. And if it was on an exam, they would say, solve for n algebraically. So NC2, again, the formula is not hard. You'd have an n factorial, you'd have a 2 factorial, and what else factorial would you have on the bottom? Because the bottom ones always add up to the top one. N minus 2. And this is equal to 28, sorry. So how do we simplify factorials? Well, we always expand the bigger one. First of all, the factorials that I want to simplify are right here in this green box. 2 factorials equal to 2. Can you see that I couldn't multiply both sides by 2 to get 56 on this? Then when simplifying inside the green box, we always expand the bigger factorial. So you have to ask which is bigger, n or n minus 2. And n is bigger, so we start. We multiply n, and then 1 less. N minus 1, and then 1 less, n minus 2. And when we get to n minus 2, we say, hey, that would keep on going. I can add an exclamation mark to say that one keeps on going because I have an n minus 2 also on the bottom. And that nicely simplifies. And so what am I left with? Well, now I've got a quadratic equation. N squared minus n, if I move the 56 over, equals 0. This factors nicely. N, and minus 8 and plus 7. So n is equal to 8 and n is equal to negative 7. But we can never do negative factorial, so if I check my work, the minus 7 doesn't work. So the only answer is n equals 8. Some of them will be algebraic. Some of them, the best you can do is guess and check. I mean, for D, 6 choose R is 20. Does it make sense that you can never have 6 things and choose 9 of them? Right? There's 6 prizes. Go ahead and pick 10. You'd be like, yeah, pick 10 of them. There's only 6. Doesn't work, right? So for this, well, it's not going to be 6 choose 1, because that's only 6. So now, there's not too many to guess before you would get it right. Try 6 choose 2, you get 15. And that means you've also done 6 choose 4. That'll also be 15. Do 6 choose 3, and it probably works out, because we've tried all the other ones. So then R would equal 3 just by guessing and checking. It does work. 6 choose 3 is 20. Okay? Same thing with this, n choose 4. You could try it algebraically. Sometimes algebraically it gets really complicated really quickly. Like in this one, n choose 4 would be n factorial over 4 factorial, and you'd have n minus 4 factorial equals 35. Okay? So 4 factorial is 24. What is 24 times 35? 35 times 24. I'm going to actually show you a little trick on this one. And if I expanded the bigger one, I'd have n times n minus 1, n minus 2, oh my goodness. There we go. N minus 3, and n minus 4, which I'd finally be able to say I can cancel out. This would be one that they could ask you to do it algebraically, but they won't. I have n minus 1, n minus 2, that's a 2. Yeah, everybody can see it's a 2. N minus 3, and 35 times 24. If you wanted to solve this algebraically, you'd have to multiply it all out, and you would get an n to the 4. And let's just take out our kit. What is 24 times 35? You would get an n to the 4, and 24 times 35 is?
840.
840. And you would have to use chapter 1, your factoring with the factor theorem, remainder theorem, and synthetic division with an 840, and try things until it works. They won't ask you that because it's too complicated, but there is a shortcut for this one, which is kind of cool. The shortcut is noticing that this n, n minus 1, n minus 2, n minus 3 is like 4 numbers that are consecutive, going down by 1 each time. And it has to equal 35 times 24. Could you break up 35 times 24 into 4 numbers? What could you break 35 up to? 7 times 5? Could you break up 24 to 6 times 4? Do I have 4 numbers in a row? Can you see it could be 7, 6, 5, 4? And so n is equal to 7. The number that's the biggest. That's way better than doing the factor theorem, remainder theorem, and synthetic division. So sometimes you got a mix of algebra and it's not guessing and checking. We used a strategy here, but it's not algebraic because we're kind of fiddling and not doing algebra as we're doing it. So I just wanted to show you 15 for that reason.